And good evening, everyone. Welcome to our collaborative teaching session on statistics and probability, organized by Mathematics Unit. I'm delighted to be your moderator for today's session. My name is Dr. Izni, and I'll be facilitating our discussion and activities. Before we begin, let me extend a warm welcome to Dr. Loh Yu Fang, our esteemed speaker, whose expertise in statistics and probability will undoubtedly enrich our learning experience today. We're privileged to have you with us, Dr. Loh. Okay, everyone, let me share with you Dr. Loh's background. Dr. Loh served as the Dean of the Faculty of Business and Management at UCSI University, Cheras, hold a PhD specializing in survival analysis, a master's degree in applied statistics, and a bachelor's degree in mathematics, all earned from University Putra Malaysia. She has been a fellow of the Royal Statistical Society since 2018, a member of the Institute Statistic Malaysia since 2023, and a member of the International Association of Engineers since 2021. Her active involvement in research spans advanced statistical methodologies in the field of survival analysis. He has also been actively involved in research related to advanced statistics. Dear all, this session is designed to be interactive and participatory. So I encourage everyone to engage actively, ask questions, and share your thoughts. Kindly help us to unmute your speaker, please.
Oh my God!
Host can help me to mute Nurul Fashiha. Nurul Fashiha, please unmute your mic, please.
Apa kita food science lah, memang lah.
Encik Syarif, boleh tolong unmute tak Nurul Fashiha?
Isha, abang ini masak ke Isha?
Mute Nurul Fashiha.
I got your call.
Okay, it's okay. Dear all, this session is designed to be an interactive and participatory, so I encourage everyone to engage actively, questions, and share your thought and experience during the Q&A session.
Kenapa diorang call ni? What?
Please mute your mic. Thank you, everyone. You are here, all of you, to learn from each other and deepen your understanding of statistical concepts and probability theory. Throughout the session, feel free to use the chat function to share your comments in WebEx and also YouTube, questions or any insights that arise. I'll be monitoring the chat and will ensure that Dr. Loh addresses your inquiries as we progress during the Q&A session. So without further ado, let's dive into our exploration and statistics and probability with Dr. Loh Yu Fang. Dr. Loh Yu Fang, the floor is yours. Thank you.
Thank you, Dr. Izni. Good evening, everyone. Thank you for spending your Saturday night, Friday night with me. I just wonder why you are so hardworking Friday night. Okay, so let me share the screen first. Can you see the screen? Can you see the screen?
We can see the screen. Yep.
So I can start now.
So
I was tasked to discuss on the discrete probability distributions where we cover binomial Poisson and also for continuous distributions, which is normal distributions. But the slide is quite a lot, lengthy. I try to cover as much as I can for discrete first. If we have time, we cover for normal distributions. So basically, for this lesson today, we will cover the basic of the probability distributions, followed by the calculations on how to get the mean, variance, and standard deviations when you have probability distributions. Then followed by the special distributions where you have binomial and Poisson. If I talk too fast, you stop me. So upon completing the chapters, you should be able to construct probability. Wait, I need to move the construct the probability distributions for random variable, and then find the mean, variance, and deviations, and get the exact probability for x successes in the n trials of binomial experiment, find the mean, variance, derivations when you have a binomial case. And lastly, we also cover Poisson distributions. So just a refresh, what is the definition of a variables? When we say about variables, it means that something that will be varies. So it will be a characteristic or attribute where you can assume different value. So usually we will use alphabet, for example, X, Y, and Z. Okay, what is this? Annotations request. Should I decline? Dr. Isni, I decline or what?
Decline apa?
There is an annotation request.
Oh, not view in here.
Okay,
So
I decline. I decline.
proceed.
I decline. Okay.
Alright.
So we will usually, when we have a variable, we will use alphabet. For example, X, Y, and Z to represent the variable. So what is the difference between variables and constant? Can anyone answer me? What is the difference when you have a variable and constant? Anyone? Have you heard constant before? So what is constant? Static. Manipulate, no, not manipulate. Okay, constant means that it's fixed. Okay, the numbers that is fixed. Variable is something that you assume different value. So these are the difference thing between variable and constant. So now we extend to random variable. So what is random variable? So random variables, something that assume different value. So when you have random variable, it means that the values actually determined by chance, by probability. Okay, so this is what we mean by random variable. Okay, now for variable, generally it is split into two. You have discrete and continuous. So for discrete, it's actually a fixed finite numbers. It's a finite numbers that can assume the numbers to be it can be counted, or infinite numbers. Okay, it can be counted. So long it can be counted, then it's discrete numbers. And if it is continuous, so it means that you have an infinite numbers of value, or it can be decimal, or it can be fractional value, when this value arises when you measure. So discrete when you count, continuous when you measure. So some of the example, let's say the numbers of calls that you receive every day, or the outcome when you roll a dice, or the numbers of students that we have now. So all these we count. Okay, when you count, it's discrete. Whereby when you're having fever, so you measure your temperature, body temperatures, you measure it. Okay, you measure your weight, you measure your blood pressure. So all this require a measurement device. So we call it, the variable, we'll call it as a continuous variable. So remember, when you count, discrete. When you measure, it's a continuous. So for discrete case, discrete probability distribution. So the name, it looks like, wow, what is this? But actually it's just a table. Okay, it's a table where you have one column. It consists of the values of the variable, the random variable, and another table, another column where it consists the corresponding probability of the value. So it's just a name. It looks bombastic, but actually it's a simple thing. So the probability. So this probability, it can be determined either theoretically or by observation. So it depends on the case. So how we actually construct a probability distributions? So we can make a frequency distributions for the outcome of the variable, followed by get the probability for each outcome. How you do that? You divide the frequency of the outcome with the total of the frequency. So let's say example. Did all of you receive the slide? Dr. Isni, you have a slide? Yes, yes or no?
Yes.
Okay, good. Now how I'm going to hide this one? Wait. So let's say I roll a die. Okay, I roll a single die. So the possible outcome will be, anyone? What is the possible outcome when you roll a die? Tadu.
1.
Yes, correct. Correct. Shamira. Okay. 1, 2, 3, 4, 5, 6. Yes, correct. So the outcome here, okay, I want to construct a probability distributions when I roll a die. So my possible outcome, 1, 2, 3, 4, 5, 6. Now, I want to ask, so when you roll a die, what is the chances for you to get 2? Yes, correct. 1 out of 6. How about 4? Correct. Okay. 1 out of 6 as well. It's the same. Okay. So probability for you to get 1 when you roll a die is 1 out of 6. Same thing goes to 2, 3, 4, 5, and 6. Can I proceed? Is it okay? Okay, good. Now, let's say I toss 3 coins. Okay, I have 3 coins. I toss 3 coins. So I want to construct a probability distributions for the numbers of heads I get when I toss 3 coins. So we can actually use the tree diagram to illustrate all this. So I have like first coin. Okay, let me see. Can you see my pointer? Wait. Okay, I have a first coin, second coin, and the third coin. So for coin, when you toss, it's either head or tail. So I use H to represent head, T to represent tail. So same thing, when I toss second coin, also the possible value outcome I will get is head, tail. Similarly for the third coin. So what we do here is, so how we read this one? So it is possible that when you toss 3 coins, you might get head from a first coin, head from second coin, head from the third coin. So you will have H, H, H. Same thing, you might get first head, second head, and third is tail. So with this, I can actually form a sample space. So I have first one is H, H, H. So you can see. Then second one will be H, H, T, and then H, T, H, and so on. So with this, I can actually list down total of 8 possible outcomes when I toss 3 coins. So from here, so I need numbers of head. So with this, the first outcome. So I have 3 heads here. So I will just put 3 here. And then here I have 2. Here I have 2 as well. So I summarize it. So you will see. So from here, we can observe that the possible numbers of head I have when I toss 3 coins, it will be either 0, 1, 2, or 3. So what we do here, we can put it into the table form. So my numbers of head is actually the random variable. So 0, 1, 2, and 3. Then, okay, I go back. How many 0 we have here? From here, how many 0 we have?
1,
1, correct. How many 1?
3,
How many 2?
No.
3,
3. How many 3?
1,
Yes. Total you have 8. So for 0, you have only 1. So 1 out of 8. Then for 1, you have 3. So the probability will be 3 out of 8. 4 also the same. So actually, probability also carry the same meaning as a relative frequency. So I move on now. Now, you have example 3. So you have a convenience store that sells AA battery. So this AA battery is sold in several packages. So you have like 2 per package, you might have 4 per package, 6 or 8 per package. So it says that the store actually sells 5, 2-pack, and then 10, 4-pack, 8, 6-pack, and then 2, 8-packs over the weekend. So you need to construct probability distributions for this variable. So what we do, we list down the possible outcome first. So you have the package is like size 2, 4, 6, 8. So you list down this way. Then the store sells 5 for 2 package. So you have this like 5, 10, 8, and 2. So from here, when you want to construct a probability distributions, what you need to do is you have to count the total frequency first. Okay, get the total frequency. Total you have 25, is it? You have 25. Okay, so the probability will be 5 over 25, 10 over 25, and so on. So something like this. Then 5 over 25, you will get 0.2. If you make it into decimal form, this is 10 over 25, so 0.4. Then you will see that when you total up, it will be equals to 1. Can I proceed? Okay.
Yes.
All right, good. Okay. What are the 2 requirements for a probability distributions? So like I mentioned to you just now, when you sum up the probability, it should be equals to 1. And second thing is, the probability for each outcome, it should be between 0 and 1. It can be 0, it can be 1, it can be 0 point something, but it cannot be 1 point something, it cannot be 1.3, it cannot be negative 2. Okay, so let's say you see here. So when I total up this probability, you can try total up, you will get 1. And you can observe that for each of it is between 0 to 1. Okay, sometimes you might observe that your table, when you total up, you might get 1.01, you might get 0.99, it doesn't matter because it is due to rounding error. Okay, don't be surprised, you might get more than 1, like 1.0 something, or you might get 0.99, it's okay because it's rounding error, the one no issue. So let's say you look at this example, you will need to determine whether each of the distributions is a probability distribution or not. So how you're going to do that? You have to check on these two conditions. Whether you sum up, do you get 1? And also each of it is between 0 to 1. So can you answer me for the first one? Yes or no? Yes or no? Hello? Anyone? Yes. Yes, sir. 1.1, so Camila?
Yes.
1.1, yes, sir. No. No, it is not a probability distributions. Why? Because the total is greater than 1. Okay, now look at the second one. Look at for B. Tell me whether is this the probability distributions? Yes. Okay, I get 2 yes. How about others? Yes. Okay, let's see. You total up, do you get 1? Yes. When you sum up, you get 1, and you observe that each of it, okay, each of it is between 0 and 1. So this is the probability distributions. Okay, I move on now. Now look at C. Yes or no? Yes. Correct. Okay. Each of it between 0 to 1. And when you sum up, you get 1. So this is the probability distributions. How about D?
No.
No. Why? Yes, correct. You have one of these probabilities is less than 0. It's a negative. So which is no. This is not a probability distributions. Okay, very good. Next. Okay, now we will cover how we actually calculate the mean, variance, and standard deviations. So the formulas for mean, okay, we will use mu, okay, mu to denote the mean for a random variable when you have discrete probability distributions. So how we read this one?
Sudah.
Okay, you have the first outcome, okay, first outcome of the random variable, multiply with the probability itself. Then plus the second outcome, multiply with the probability itself, and so on until the last one. So this one can be simplified with the form of summations. Okay, this one means summation. The big sigma is a sum of the product of outcome, the outcome multiplied with the probability itself. Have you learned all these things before? Yes, okay, so means that I can do very fast. All right, now can you calculate for me the mean of the numbers of spots that appears when a die is tossed? So you have an outcome, you have a probability. So if I would like to calculate the mean, I will need to get the product of each of it, like 1 times 1 over 6, 2 times 1 over 6, and so on. So this one, it will be good if you keep it into a table form. Okay, so I transform into from horizontal to become vertical. I have 1 up to 6, and then the probability. So what I do here is, I will get each of it, first column multiply with the second column. So I will have like 1 times 1 over 6, 4 times 1 over 6, and so on, and then total up. Okay, you total up, this is your mean. So you can actually put it into here. Your mu actually is the summations. So you total up all this, which is 21 over 6. Then if you want to make it into decimal, 3.5. Can I move on?
Yes.
Okay, good. Next. So you have a families with 4 children. You're required to find the mean numbers of children who will be girls. So again, you will need to list down, okay, for 4 children, like the first child is boy or girl, this and that. So what we do, I have the first kid, second, third, and the fourth. I use B to denote as boy, G denote as girl. So from here, so how we read this one? You have all 4 is boy. If you read this one, you will have like the first 3 is boy, the last one is girl. So from here, when I list out everything using a tree diagram, I can have this sample space. So I have total of 16 observations, okay, 16 outcome, and I need the numbers of girls. So let's say this one. This one I have no girls at all, so put 0. This one I have 1, so put 1. So you will see something like this. So from here, we can observe that when you have the families with 4 children, so it will be either you have no girls at all, or you might get 1, 2, 3, or 4. So from here, you can see 0, you only have 1. 3, for 1 girl, you have 4. And then for boy, 6, you have 6 with, you have 2 girls, total you have 6. And then for 3 girls, you have 4. For all girls, you have 1. So this one you have to divide by total of the 16. So from here, numbers of girls, you list from 0 to 4. Okay. Then the probability, like I mentioned just now, 0, you only have 1. So 1 out of 16. And for 1, you have 4. For 2, you have 6. So 6 over 16 and so on. This one you can simplify this one. Then I will need to multiply, okay, get the product of 0 times 1 over 16 and so on. I get this. Then total up. When you total up, this is your average. The mean is actually your average. Then you can plug in this number into your mu. Your mu equals to 2. So we can say that the mean of the numbers of girls is actually 2. Then we move on. Okay, for this example 7. If 3 coins are tossed, find the mean of the numbers of heads that occurred. So for this one, it's the same example as previous. So we already have a table. Okay, with the probability, the 0, 1, 2, 3, and its probability. Now I will need to calculate the mean. So what I do, I put into a table form, then get the product between the x and the px, get the summations, so which is 1.5. We can just plug in here. Am I too fast?
Yes.
Okay or yes? Okay.
Okay.
You just want to finish the class earlier, is it? Okay, come. Now, example 8. So same thing. If I want to get the mean for numbers of batteries sold over the weekend at a convenience store, so these are the examples just now we have. So these are the probability. So we just need to add in one more line. You can do it horizontally. It's okay. Get the product. Okay, get the product like 2 times 0.2, 4 times 0.4, and so on. So once you got this, sum up. Okay, you total up. This is your mean. So you can actually explain like on average. Okay, the mean actually is the average. So you can say on average, the numbers of batteries sold over the weekend at the convenience store is 4.56. You can explain it in this way. Okay. Next, we move on. Okay, so we have power for mean. Now, how about variance and standard deviations? So for variance, we use the symbol sigma. Okay, this one we call it as sigma. Just now I also mentioned this is sigma, right? This is a capital letter sigma. These are the Greek letter. Okay, these are Greek letter. So for capital letter sigma, it actually represent summation. And for the small letter sigma, this represent the variance. Sigma squared is variance. Okay, sigma power 2, we call it as variance. And when you only have sigma, this is standard deviations. So let's look at this. So how we actually understand this formula? Okay, you need to take this outcome, you square it, you multiply with the probability itself, then get the summations. All right, after that, use this number minus the mean power 2. So this is your variance, whereby for standard deviations, you just need to take the square root. Okay, when you take the square root of this, then it becomes your standard deviations. So let's look at this. For example, I want to compute the variance and standard deviations for the tables that I have in example 5. So I already gotten the mean, the mu just now, 3.5. So I'm not going to repeat it. So now my first thing is I need to get this. So what I do, I need this x power 2 times the probability. So 1 power 2 times 1 over 6. Okay, same thing. 4 power 2, which is 4, times 1 over 6. So you will have 4 over 6, which is 2 over 3. Then do the same thing for the rest. And total up, you get 91 over 6. So take this number, plug it into here. Then minus off the mean power 2. So 3.5 over 2, power 2. Then simplify it, you get this number. So this is your variance. And for standard deviations, you just need to take the square root. Okay, usually I will not recommend students to take the square root after you round to 4 decimal or something like that. After you have round, you take the square root, then you will have rounding error. So it is advised that you take the square root in the complete form first. Okay, so from here, you get 1.707. So this is how we compute the variance and standard deviations. So let's look at another example. So you have a box that contains 5 balls. Mute your mic. Okay. So you have 2 balls that's number 3. And then 1 ball's number 4. And then another 2 number 5. So this ball actually mixed. And you're going to select one at random. You take out one. Okay. You take out one, you record the numbers. Then after that, you put it back again. So this one you repeat many times. Then you will need to find the variance and standard deviations for the numbers of balls.
Impact tu macam ada apa
Mute
macam
your mic,
untuk satu kelas tu kena wajib dah ada ni daripada
Alicia, kindly mute your mic, please. Alicia,
Oh, sorry.
thank you.
Okay.
You,
So
Dr.
now,
Loh.
thank you. Okay. I will talk very fast. I finish you. I let you go earlier. Okay. Now, we let the x be the numbers of each ball. Numbers on each ball. So you have like what? 3, 4, and 5. So for 3, you have only 2. So 2 out of 5. Then for this 4, you only have 1. So 1 out of 5 and so on. So I can actually form this table. Okay, with 3, 4, 5, and I form the tables. And you can try, you see, each of it is between 0 to 1. And when you total up, you get 1. All right. Now, how we actually get the variance and standard deviations? So again, you put into table form easier for you. So get the 3 times 0.4, you get this. And then this one will be 3 power 2 times 0.4. Then the total. So with this, this is my mean. Okay, on average, the numbers is 4. Then for the variance, you are going to take 16.8 minus the 4 power, which is 0.8. Then for standard deviations, you take the square root. Okay, why we straight away take here? Because this is already the exact number. Okay, 0.8. I straight away take the square root. I get this 0.8944. Okay, now I have a question. What is the meaning of standard deviations? Can anyone answer me? We gotten the variance and standard deviation. So what is this standard deviation actually tell you? Anyone? How much a set of data deviate from each other? Almost there. Yes. How the data disperse around the mean? Yes, correct. Okay, how far they are on average, the data actually apart from the mean. Okay, you get it correctly. Very good, huh? Now, move on. So you have this example, top radio stations have 4 telephone lines, and then you have this, what is that? All lines are in use, other who are trying to call busy signal. So probability 0, 1, 2, 3, 4 shows this here. Okay, you have a x 0, 1, 2, 3, 4 with the probability. You are required to find the mean, variance, and standard deviation. So again, we put into table form, then get the product of it, sorry. After that, get the summations, then plug in into the formula. you got the answer. Okay? Simple? Should be no issue for you. You have done it before. So I move on. Okay, now, fish out. Probability that the numbers of customer of a day, okay, with the probability distributions given here, and then you're required to find the mean, variance, and deviations. So again, you put into table form, and get the product of each of it. After that, the total, then you plug in. You will get this answer. You have too much example. Can I move on? Basically, they are the same. Okay, I move on. All right, now let's go to binomial distributions. So before we go into the distributions, let's learn about what is binomial experiment. So binomial experiment is actually a probability experiment, okay, where it satisfies the following requirement. So the numbers of trial, they must be a fixed numbers of trial, and for each trial, you will only have two outcomes, okay, two possible outcomes, either success or failure. When you have more than two, or when the outcome it can be reduced to two, then we can also consider that. Then each outcome of the outcome of each trial, it must be independent of one another. So it means that the first trial, what is the outcome? It will not affect the second outcome of the it will not affect the outcome of the second trial. All right. And the probability of success, it must remain as the same for each of the trials. So these are the four basic requirements to fulfill the binomial experiment. So the outcome of this binomial experiment and also the corresponding probability for the outcome, it will form out a distributions where we call it as a binomial distributions. So these are the basic symbol. Usually we have like this symbol of the probability of success. So you have P, capital letter, bracket S, and for F represent the failure. So the small letter P represent the numerical probability of success. Q represent numerical probability of failure. So this one we hardly use. We usually always focus on like P and Q. Then N stand for numbers of trial. The X stand for numbers of success in an N trial. And take note that your numbers of trial is an N, and this X it should be between 0 to N. It cannot go beyond negative. It cannot go beyond N. So it can be smaller as 0, okay, 0, 1, 2, 3, and the largest only N. So your X is between like 0, 1, 2, 3 up to N. So binomial experiment. If you want to have a probability of exactly X successes in N trial, so it will be something like this. So usually this one, NCX, we call it as a binomial coefficients. All right, binomial coefficients. You can write it this way, NCX, or you can write it this way. You put a big bracket, the top you put N, the bottom you put X, but don't put the line here. There's no line here. It's like this. This one is binomial coefficients. Then it will be multiplied with the probability of success, where power X. How many X you have? And then times probability of failure, and then N minus X. So you can observe that when you sum up these two, you take the N, the X plus N minus X, you get back N actually. And then your P and the Q, when you sum up, you actually get back 1. All right. So if you want to use the formulas to get this NCX, you can get it here, but which is not needed because your calculator can get it for you. Okay, calculator can get it for you, so no need to memorize all these things. So anyone using which one? Total easy, they're using which calculator? Which model? Cannot hear you. Total easy, they're using which model?
I'm using scientific apa entah?
570 EX 50570
MX. 570 MX. Is it? Okay. Anyone using 350 MX? No, Wow, this one you use the white color one. Okay, anyone using 350? No, Okay, I move on if no. Okay, this one, 570 MX. Anyone? Dr. Isni. The rest? Yes. Okay, if I want to get this NCX, how I get it? You input the numbers of trial first, and then you use this one. Okay, shift divide. Do you see this one? NCR? Do you see NCR above the divide here? So this is how you get the NCR, NCX. Okay, they are same meaning. So key in the X, then you will get answer. So for example, if I have 10 trials and then 7 success, so I will need to key in 10 and then shift divide 7, press equal. What do you get? I know. For those who are having 570 MX, what do you get?
120.
120, yes, correct. Correct, 120. Okay, now, how about this? Anyone using 570 EX plus? Anyone? Yes, no, I move on. Okay, how about this? White color casing? White color casing? I think some of you are using. Okay, so where is the NCR? Here. Here, can you see that above the divide button? So again, same thing. If I need to get the 10C7, so I just key in 10, shift, divide, 7, then press equal sign. You should get 120. All right? Can you get it or not? Anna?
Can.
Okay, good. Now, you do. Give me the answer. The first one is what? 10 No, 20. 10. Okay, 10. Second 35. 120, correct? C, is it 120? Okay. D, 792. Yes, correct. Okay. Do you notice that? Wait, do you notice 10 C7 actually is the same as 10 C3? Do you realize it? Yes or no? Both are 120, right? Correct, So basically, your n, x is the same as your n and then n minus x. They are the same, all right? Just to let you know. Okay, now good. Move on. So inequality symbol. So when we deal with like discrete or continuous case, the question always like you need to know about the inequality symbol because you are using a wrong symbol, it will lead you to the wrong answer. Okay, so this is very important. So when you have a question saying something like less than, fewer than, or lower than, then you should expecting to see this kind of symbol, less than. And then when you have the question mentioned like at most or maximum, so it means that it can be smaller than or it can be up to this number only. And when you have, for example, exactly equals to, then you put equal sign. And let's say you see the question is like more than, greater than, or exceeded. So this one greater sign. If the question mentioned like at least the numbers or minimum this, so it means that it should be equals the numbers or greater than that. So greater than or equals to. So this is very important. Take note. So let's say you have a survey or what? 1 out of 5 Malaysians say he or she has visited a doctor in any given month. So 1 out of 5. Then when you select 10 people, you want to find the probability that exactly 3 will have visited a doctor last month. So our event is whether they have visited a doctor or not. Okay, our success event, whether the person visited a doctor or not. So you have a total of 10 people. Then you are looking for exactly 3. So what is the probability that the person will visit doctors? Where can you get the number? what is the probability that the person will visit a doctor? From where you can get? Yes, correct. 1/5. Here, you have here. 1 out of 5 visited a doctor. So this is the probability of success. So you get it correctly. So once you have all this info, so I put it here. I have 10 trials. So n equals to 10. I have probability of success 0.2. So once I get the P, I will be able to get the Q because P plus Q equals to 1. So once I get P is 0.2, I will automatically get the Q is 0.8. And the question asking for exactly 3. So your X equals to 3. So now what I do? You see, you have N, you have P. This is binomial. So from here, I am going to apply this into the formula. So plug in into this formula. You see your X equals to 3. Your N you plug in is 10. Then this one X is 3. P 0.2. And then your Q is 0.8. So with this, then I can key everything into my calculator. I will get this. Usually probability, we will leave it in 4 decimal places. So would you like to try? See you can get the same answer or not? Again. Okay, then I move on. Now. Okay, good. Look at this one. Try to extract the information first. What is your N? What is your P? What is your Q? Okay. Hello? Anyone? N equals to 5. Yes. P 0.3. Correct. Q. Yes, correct. Correct. Okay. Now, find the probability that at least 3 of them will have part-time job. How? What is the symbol? At least 3. Anyone? More than or equals to? Yes. Correct. Greater than or equals to. So you see, you have the possible value, you have 5. You have 5. So the possible value of x is 0, 1, 2, 3, 4, 5. Then you need at least 3. So when at least 3, you will have this 3, 4, and 5. So how we actually turn this question into mathematical form? If these are the information that you give it to me just now, then greater than or equals to 3. So you have this. It means that your x is 3, 4, and 5. So from here, I will put it into the probability form. So for probability, make sure you put the bracket, the P bracket, okay? So this one means the probability that x greater than or equals to 3. So from here, how we do that? So we know that this is discrete case. So your x can only be like 3, 4, and 5, but it cannot be 3.2 because it's discrete case. So from here, you're going to have probability when x equals to 3 plus probability when x equals to 4 plus probability when x equals to 5. So here, you're going to substitute. When you see x is 3, you put in here. Okay? And then when x is 4, put in here. When x is 5, put in here. So 1 by 1. Then I have this form. Then get it from a calculator, simplify it, and you will get the final answer. So you might wonder, in your calculator, you will see this. Okay, for the third one, this one. You will see this. Some will not know how to do it. So this one actually is a scientific notation. When you see -3 means that you move to the left 3 times. Here, wait, let me get my... From decimal, 1, 2, 3, then dot. So you have 0.00243. So you get this. All right. Then if you want to leave it in 4 decimal, you round up. So this one is 0.1631. Okay, I continue on. All right, next. First. You have 5 multiple choice questions. Each question has 4 possible answers. Find the probability that student get exactly 3 correct. What is the probability for getting a correct answer for each question? What is the chances for you to get the answer correctly? You have an MCQ. No. You have MCQ, and then MCQ, each question has 4 answers. So A, B, C, D. So you only have 1 correct answer. 1 out of 4 correct. Okay. The chances for you to get correct answer is 1 out of 4. So the probability of success is 1 out of 4. Total observations, you have 5. So you have N equals to 5, and then P is 0.25 because 1 out of 4, your Q is 0.75. And you're looking for exactly 3. So when exactly 3 means your X equals to 3. Then we plug in all the informations into the formula, and then use your calculator, you will get the answer. Correct, huh? You have 4 questions, you have 4 possible answers. There is only 1 chance to get it correct, right? So 0.25, the P is 0.25. Okay, I move on, is it okay? All right, good. Okay, survey of fear of being home alone at night. Okay, read these questions. Read the questions, identify whether is this a binomial case. If yes, then get the numbers of trial and also the probability of success. The success event is whether the Malaysians being afraid or not, afraid of being home alone. Huh? This is a success event. So what is the probability of success here? 0.05, yes, correct. All right, numbers of trial? What is your N? 20, yes. Okay, you have N, you have P. Okay, this is binomial. Now move on. Okay, we go one by one. Exactly 5, at most 3, at least 2. So let's move on to the first one. Exactly 5. So your X equals to 5. Okay, X equals to 5, and you have all these informations. So plug it into the formula here. Then you will get this answer. So this one is straightforward, very straightforward. So I move on. When you have it here, oh, this one. When you key into a calculator, you will see something like this. So same thing. When you have negative 3 means that you move this one decimal to the left hand side 3 times, then you will get this. So this is 0.0022. So how you actually explain this one in layman term? When you want to explain it so that people will understand, you will multiply this one with 100 first, make it into percentage form. So what do you get? 0.22%. Okay. There are 0.22% that exactly 5 people in the samples were afraid to be home alone. Something like that. All right. Now, let's move on. So you have at most 3. Okay, at least now your numbers of trial is 20. It means that your possible value of X will be between 0, 1, 2, 3, up to 20 here. Okay, now when we say at most 3, at most 3, so what is the numbers? What is the possible value of X? 0, 1, 2, 3. Yes, correct. At most 3 means maximum is 3. So you're going to have this 0, 1, 2, 3. Now we turn it into mathematical form. Okay, at most 3, make sure you use the correct symbol, less than or equals to 3. So this one, when you have X less than or equal to 3, it means your X equals to 0, 1, 2, and 3. So you're going to get the probability for each of it and then sum up. So what I do, same thing. I plug in whenever I see X, I plug in 0. Whenever I see N, I put it as 20. When I see P, I put 0.05. Q, I put 0.95. So do one by one, slowly. Then keep everything into calculator and get the final answer. You should get this. So how we can say this? You have about 98%. Okay, 98% chances that at most 3 people in the samples who are actually home alone, scared of home alone. Can I move on? Can I? Okay. Now, see, at least 2. So look at the bottom, the box there, the 0, 1, 2, 20, up to 20. What is the meaning of at least 2? So what is the numbers? 2, 3, 4, up to 20. Yes, correct. Okay, 2 up to 20. Wow. So you imagine how many numbers you need to key in. How many probability you need to calculate? There's a lot, right? So what is a smart way to do it? So when we say at least 2, make sure you use this greater than or equals to 2. So I have this. Then, okay, are you going to find one by one? X equals to 2, 3, up to 20. That is a lot. Okay, we're not going to do that. Okay, this is not a good way. So instead of getting this 2, 3, 4, we use complement. Okay, we use complement. You can actually use 1 minus the probability when x equals to 0 and 1. So you will get the same answer. Yes, correct. So instead of doing this, we do this way, smart way. So I just need to get these 2 and I will get answer. Done. All right. Can I move on? All good? All good, yes, okay. Enough for today? Oh, I haven't finished yet. Okay, come. Example 16. Okay, read first. See what you can derive. You tell me what is your N, what is your P here. What is your N, what is your P? N 15, P? N is 15, correct? Your P? 0.7? Yes. Okay. You have a samples of 15 single vehicle traffic fatalities. Okay. So this is the numbers of trial. And then what you have? Occurred at night. Okay. Involve intoxicated driver. So 0.7. Your success event is this. Okay. This is the probability of success. And you're looking for probability between 10 and 12 inclusive. So when 10 and 12 inclusive mean including 10 and 12. So 10, 11, and 12. So it will be this way. This is the one you're looking for. No, you have 15. So I listed the possible value of x. And you're looking for this 10, 11, and 12. So now we are getting the summation of the probability when my x equals to 10, 11, and 12. So make sure you use the correct symbol, okay, which is your x is greater than or equals to 10 and less than or equals to 12. So from here, list down, and plug in all this into the formula, and you will get answer. I move on, Okay. Now, example 17. 90% of all the people between the age 30 to 50 drive a car. So you are looking for the probability that in a samples of 20 people, okay, you have all these questions. So from the first sentence here, can you identify the numbers of trial and the probability of success? 20, okay, correct. And 20, P 0.9, yes. All right, now let's move on to this. Exactly 19 drive a car. So your x equals to 19. More than 17, so greater than 17. Fewer than 18, less than 18. So we look at the first one. These are the info. N20, P 0.9, so your Q is 0.1. Then, so exactly 19 drive a car. Just plug in X equals to 90 and put it into your calculator, you will get an answer. Then, for more than 70, so I list down because you have 20, total of 20, so 0 up to 20. So more than 17, which number? Which number? More than 17? 18, 19, 20. Yes, correct. Okay, 18, 19, and 20. So I'm looking for the probability for this. So make it into mathematical form. Okay, P, X greater than 17. Then it's actually X equals to 18, 19, and 20. Then key into the formula. After that, simplify it and you will get the summation. Okay. All good? All right. Okay, I move on. For C, fewer than 18. So fewer than 18, which number? Which one is fewer than 18? 0 to 17. Yes, correct. 0 to 17. That is a lot. Okay, we use complement. Okay, don't count one by one. It's too long already. You're wasting your time. So we use complement. Okay, make sure you use the correct symbol. When it's fewer than 18 means less than 18. Okay, don't put equal sign. So it's actually 0 to 17. Gone. We use 1 minus. Okay, 1 minus the one that is not shaded here. So 18, 19, and 20. And then plug in. So I got the answer. If you have time, you can try to use this one to play around it. See if you can get the same answer or not if you have time. I'm not going to do that. Okay, can I move on? Okay, good. All right, now, so when you identify distributions as the binomial distributions, so you can actually use this formula to get your mean, variance, and standard deviations. I'm not saying that the previous one that is wrong. The previous one that we learned is actually applicable as well for these binomial cases. It's just that once you identify that it is actually a special binomial, okay, it's a binomial case, you can actually use this formula to get the means, variance, and standard deviation, which is much more faster. So for mean, it's actually n times p. And then for variance, n times p times q. Standard deviations, take the square root. That's it. So really fast. It's just that you need to identify whether it's a binomial or not. If yes, take the value of numbers of trial and also the probability of success. Then you will get it. So let's say I have this. A coin is toasted 4 times. Find the mean, variance, standard deviation of the numbers of head they will be obtained. So you have coin toasted 4 times means that your number of trial is 4. So when you toast a coin, you will be either getting a head or a tail. So either you have only 2 outcomes. Okay, 2 outcomes. Your success is head, getting a head. Your fail event is actually getting a tail. So the chances for you to get head when you toss a coin is actually 1 out of 2. That's why your P is 1 out of 2, 0.5. When you get a P 0.5, automatically your Q is also 0.5. So I have N and the P. I can actually use the formula that I have in the previous slide to get the mean, variance, and standard deviations. So from here, my mean very fast, just 4 times 0.5, I get 2. And then variance, just multiply N, P, and Q. Get 1. Standard deviations, you take the square root of 1, which is also equals to 1. This one is very simple. If we move on to another example, when you roll a die. So this die is very special. It's actually 8-sided. It's not the ordinary one. It's 1, 2, 3, 4, 5, 6. This one you have 8-sided. So the side has like numbers 1 up to 8. So this die is actually rolled 560 times. Okay, 560 times. You're required to find mean, variance, and standard deviations when you have a number 7. 7 that will be rolled. So in this case, okay, we identify first, do you have number of trial? What is your number of trial here? Anyone? Yes, 560. Yes, correct. You have the numbers of trial as 560, and then your event, success event is getting number 7. Okay, number 7. So when you roll a die with each side, what is the chances for you to get 7? Correct? 1 out of 8. Correct. So you manage to get the N and the P. Automatically, you can get the Q. So from here, just plug in. All right? Then you will get the answer. Easy? Yes, huh? Okay, I move on. Okay, here. 65% of Malaysians favor sentencing drug driver to jail, even if they have not caused an accident. Random numbers of 1,000 individuals selected. You're required to find mean variance deviations of the people who fail this way. So can you identify the numbers of trial and the probability of success? And 1,000 P 0.65? Yes, correct. So your Q will be 0.35. All right. So plug in. Would you like to try first? Would you like to try to get your mean variance deviation first? I give you 1 minute.
Okay, first person answer the question, I will give duit raya.
Siap Raya.
Okay,
Okay.
Ilmi Mariha. But correct or not? Correct or not?
I
Only
think correct.
answer.
I think correct. Correct.
Okay, Ilmi, you will get duit raya from me.
Wow.
Okay, carry
Correct.
on.
Okay. All good, huh? All get the answer?
Seburu gelap. Tak tahu kenapa seburu gelap.
Martin Hasana, kindly mute. Okay.
Jawapan dia 15.08.
So can I proceed?
Yeah, sure.
Yes, huh? All right, next. Now, Poisson distributions. So I give you time to do, huh? Okay, again. So Poisson still considered as it's a discrete case. All right, it's a discrete case, but it's a special case. So when you're going to use it? When your N is very large. Okay, it's like binomial, but the numbers of try is very large, a big number, and the probability of success is very small. Okay, and you will observe that this variable occurs over a period of time. All right, so when this is the case, we can actually use Poisson distributions. So when we can actually use this Poisson, when you have like a density of item distributed over a given area of volume. Let's say it's given like the numbers of plants growing per acre, or the numbers of defects in a given length of a videotape. So all this you have like, for example, fixed period of time or fixed length, something like that. So we can actually use Poisson. So I show you some examples. So before this, let's check on the requirement first. So Poisson experiment, again, is a probability experiment where it satisfies the following requirement. So X is the numbers of occurrence of an event over some interval. Like I mentioned to you, like maybe on certain length or area, volume, or period of time. So you have specific interval, okay? And the occurrence occurred randomly, and it is independent of one another. And you are given an average numbers of occurrence over an interval. It is known. So you'll be given all these informations When you see something like this, then you can actually use Poisson. So what is the formula? Probability of X occurrence in an interval of time, okay, volume or area for variables where, okay, this is, we call it as lambda. Okay, lambda is represent the mean numbers of occurrence per unit. Okay, usually for Poisson, we use lambda to represent the mean. You can also find that some books actually use mu because both represent the same thing. That actually means mean, average. So this Poisson, the formula for getting the probability, exponent power negative lambda times lambda power x over x factorial. So again, because Poisson also a discrete case, so you won't see 0.3 here. Your possible value of x is start from 0, okay, 0, 1, 2, 3, up to where? You don't know where you stop because your n is very large, okay? So what is the difference between binomial and Poisson? Binomial, you know clearly your n and your p. But in this case, for Poisson, you will not see n because your n can be very large number and you don't have a p here. But what you have, for Poisson, you have mean. Okay, this is how you differentiate. For binomial, you have n and p. For Poisson, you have mean. Okay, so E is actually the constant. Okay, it's a constant which is equal to 2.7183. You are with your calculator, right? May I ask? You have one E that is in yellow color, another one E is in red color, right? So what's the difference? Can anyone answer me? You have two E in your calculator, one in red color, one in yellow color. So what is the difference? Dr. Isni, ada duit raya lagi ke?
Okay, one more duit raya. For first correct answer. So the winner is
The red E is a constant, and then the yellow color E. No.
okay, wrong.
Almost there, almost there.
Almost there, okay.
Exponential, yes, both represent exponential, yes. Exponent. It's not exponential, exponent.
Okay, so the
Anyone?
winner is Hazira.
I think you have to give me the duit raya lah. I know the answer.
Okay, after this.
Okay. No one, ah? No one, ah?
Oh, no winner. Okay.
E, red E is E power 1, and then yellow E? What is yellow E? Almost.
Almost. Come on, Camila. We're almost there.
Yes. Oh, you have to give two duit raya already.
Duit raya, eh?
Ah, the
Okay.
word. Okay. The
Okay,
red
Camila
color
can have
E, yes. Red color E is actually E power 1. Okay, red color E is E power 1, whereby yellow color E, it can be 1, it can be any other number. Okay, just to let you know, red color E is actually E power 1. Yellow color E, it can be any number. Okay, up to you to put in. All right, okay, good. Now we move on. Okay, kesian Dr. Isni. Okay. Now, look at this. Example 21. So you have 200 typographical errors randomly distributed in a 500-page manuscript. So you see, you have like a fixed interval. Okay, the interval is 500 page. So now you want to find probability that a given page contain exactly 3 errors. So how we do it? Do you have any average or not from here? 500 page, you have 200 errors. Okay, how about one page on average? What can you do? Anyone? Because here the question is actually asking a given page. So you only have one page, all right? But now you have this 200 errors is actually over 500 pages. Yes, correct, Shamira, yes, correct. So you will need to identify the mean numbers of error. So each page has average of? Yes, you have 500 pages. So you have 200 errors. So on average, you have 0.4. Okay, 0.4 error on one page. Okay, so once you found the lambda, then you can actually plug in. What is the question? I forgot already. Exactly 3, yeah? Okay. So when you need exactly 3, so again, we use this formula. So whenever you see lambda, plug in 0.4. Whenever you see 3, you plug in 3. Then you get the answer. So you see something like this in your calculator, move it to the left hand side 3 times. Then you get this 0.0072. All right. This one, any problem so far? All good, huh? Okay, now move on. So what is the meanings of here? If you want to interpret this one, so you can actually multiply this probability with 100. So it's actually less than 1% chances. Okay, it's actually less than 1% chances where any given page you have exactly 3 errors. This is very rare that you fit one page and you found 3 errors, because the chances for you to get this is actually less than 1%. All right, this is how we actually explain it. Now, okay, you try this. It have tells you that it's follow the Poisson distributions and then average 4.5 every quarter of an hour. So your interval is quarter of an hour, 15 minutes. Calculate the probability of fewer than 3 arrivals in the quarter of an hour. Anyone? You calculate first, try. How long you need? 1 minute? 1 minute? Belum siap ah? (0.1736). Anyone have a same answer? 1736. Shamira, why? Hey, I only get answer from one student. How about the rest? Yes, Alia, Amali? 1736 Hui? How people get a different answer? How about others? Anyone? One 1736. So I think 1736 are wing already. Okay, let's look at it. So when we have fewer than 3, all right, fewer than 3 means you have less than 3. Okay, reminder that Poisson also a discrete case. So fewer than 3 is 0, 1, and 2. Okay, so you're going to put in this way, then plug in one by one. Either you take out the common term, or you can just calculate one by one. Okay, you get this? Very fine, you got this. Okay, I have a question. 0 factorial is 0 or 1? 1. Why? Why? I know you press calculator, so y is equal to 1. Why 0 factorial is equals to 1? Anyone? Tutor is ni, Duit Raya.
Duit Raya maximum 3.
Anyone? Why 0 factorial is 1?
Okay. I think they are typing the answer. Okay, Aizat, each answer is divide and get 1.
Each answer is divide and get 1. Simpan lah Duit Raya tu.
Simpan Duit Raya lah.
It's okay, I'll let you know later. I'll let you know later.
Tu that got the answer.
1 divide 1 is 1. 1 divide 1 is 1.
There are no positive values less than 0.
Never mind, later I explain. Okay, see later if those in the chat boxes get the correct answer, then Dr. Isni, you pandai-pandai ya. Give Duit Raya. Okay. Okay, so 0.1736 is the correct answer. We move on to the next one first. Before I answer you, why 0 factorial is 1? Okay, just now for this, we actually get each of the probability and then we calculate it first and then only we sum up. But actually we can simplify first. So let's say this one, you can see the common term. You will see the common terms here, which you have exponent negative 4.5. So take out this. Okay, take out this, it become here. And then any number power 0, you get 1. 0 factorial is 1. So 1 over 1, you get 1. 4.5 power 1, you get back the 4.5 itself. 1 factorial is 1. Then 4.2 power 2 over 2 factorial. 2 factorial is 2. Dr. Isni, they have learned the factorial, right, Dr. Isni?
Sorry, come again?
They have learned factorial or not? Yes, right?
They have learned the Poisson, yes.
Factorial, yes, right?
They are not really learning deep into factorial, but they are only learning on Poisson by using factorial.
But they know how to get the factorial from
Yes,
calculator, right?
using calculator, yes.
Okay.
Okay.
Oh, okay.
Yeah.
So maybe I just give a brief idea. When you have n factorial, it's actually n times n minus 1 times n minus 2 times until you get 3 times 2 times 1. So basically, if you have 5 factorial, it's actually 4. It's actually 5 times 4 times 3 times 2 times 1. You can try. Okay? If you have 3 factorial, it's actually 3 times 2 times 1. So if you have 2 factorial, it's actually 2 times 1. That's why 2 factorial is equals to 2. Okay? You can try later. So from here, so I can actually simplify in this form, and I just need to get the summation from here. After that, only I multiply with exponent power negative 4.5, and I can get the answer. Okay, wait. Where is it? Where's my final answer? Oh no. Okay, now, I think most of you actually know how to get this exponent power negative 4.5. Just show you here. Your exponent is actually on top of ln. Where's ln? Here. If you are using 570mx, your ln is here. Okay, you can see the yellow color E and the red color E here. So red color E means E power 1. Yellow color means you can E power anything. Alright, now, so to get exponent power negative 4.5, you press shift ln. Okay, shift ln, then put this. Use this is better because it represents negative. Alright, then 4.5, then press equal sign. So you should get 0.0111. Alright, you try. And for another model, this one no one using, right? So I will skip. Where is it? Yellow color, wait. Your white color casing calculator, this one, also the same. Okay, white color casing calculator also on top of the ln. So just use the shift ln, you will get it. Okay, now you try this. On average, you have 3 calls per hour. So for any given hour, find the probability that you will receive the following. Okay, you try. You try tapi tak ada raya
Okay, everyone, try to answer the question.
Dan okay, I give you the final answer. You try it later. When you have at most 3 core, most 3 core means maximum is 3. So you have 0, 1, 2, and 3. So the symbol is less than or equals to 3. Plug in. Final answer is 0.6472. Okay, you write down first. Is it recorded, Dr. Isni?
Recorded?
Recorded, right? Is it? No. Is this video recorded? No.
Don't think so. This
Oh,
is
it's
not
okay.
recorded.
Then it's okay. I give them time.
Mm.
So the final answer 6472. You write down. Yes, correct. My Sarah, correct.
Dr. Loh, sorry, but I think YouTube got the recorded.
Oh, okay. It should be fine.
Yeah.
Okay. Next, at least 3. So when we say at least 3, means 3 and more. Okay. So 3, 4, 5, 6, and so on. So as I mentioned to you, Poisson, you do not know what is your n. Of course, you can have a long, like you can do up to like maybe 20 or 30, but it will be no meaning, because so when you get the n, your numbers get larger, your x get larger, the probability actually equals 0. So instead of doing this, you use complement. Okay, use complement. 3, 5, 2, 8. Let me see correct or not. Hey, different now. So you check your answer. Your answer should be 5768. Okay, 3 or more, at least 3. So greater than or equals to 3. So we use complement 1 minus 0, 1, and 2. Then it should be 5768. Okay, I move on. Probability of 5 or more. Okay, 5 or more. So you have like 5, 6, 7, 8, 9, 10, and so on. So again, we use complement. Use 1 minus rest. Okay. So your final answer should be 1848. Done? Okay, correct. Next, now, bit tricky. Look at this. Your life insurance salesman sell on average 4 life insurance policy per week. So in a week, it sold 4 on average. Use Poisson law to calculate the probability. Okay, in a given week. So you see the keywords are here. The average is per week. And now you are looking for a given week. So same, the lambda can be used for these questions. So your lambda equals to 4 here. So some policy, 2 or more, but less than 5. Okay, this one, assuming that there are 5 working days per week. What is the probability that a given day? So you see the difference. Here is week and here is day. So this one is slightly different. Let's work out on the A and the B first. So for A and the B, A is like some policy. So some policy means that you should have 1 policy, means consider some policy. So you can just, it will be like 1 policy, 2 policy, 3 policy, and so on. So when we say some policy, so what we do, we use complement. So 1 minus, you didn't sell anything at all. So x equals to 0. So you will get the answer 0.0183, which is when your x equals 0, then you should get 9817 for these questions. And then for B, 2 or more are less than 5. So 2, 3, 4. 5 is not counted because less than 5. All right. So you have this kind of inequality symbol. So x greater than or equals to 2 and less than 5. This one is without equal sign. So this is actually 2, 3, and 4. You plug in into the formula and get the answer. You have 5, 3, 7, 3. Okay, I move on. Okay, now look at the C. This one a bit different. This one, you have to work out a new lambda. The lambda just now that you have is for a week. So now a day. So you have 5 days in a week. So you want to get the average that how many policy actually the salesperson sold for a day. You will need to take 4. On average is 4, right? Out of 5 days. So this one, on average, 1 day, the salesperson actually sells 0.8 policy. So you have a new lambda here. You're no longer using the lambda equals to 4. So when equals to 1, you just plug in the new lambda, which is 0.8, and you get the answer, 3595. So don't use 4 as the lambda, okay? The difference between here is that what we call the interval or the period of time has changed. Before this, the lambda given is a week. Now the lambda is a day. So you need to have a new lambda. I hope you understand this. Okay, I think almost there. Is it here? So this one, you have a Poisson, and then every 20 weeks, you have an average of 3 failures. You want to calculate probability that there will not be more than 1 failure during a particular week. So again, you see, the lambda given is for 20 weeks, but you only want this particular week. So what we do, the lambda is not 3, it's 3 out of 20, because for 1 week only. Then there will not be more than 1 failure, so less than or equals to 1, not more than 1, so 0 and 1. Then just calculate and you will get the answer, 0.9898. Okay, I think I have done this. Let me show you another one. Hey, I don't have a lambda slide. I think I have removed it. Okay, I have completed for the binomial and Poisson. Any questions so far before I move on to the normal distribution? No, all good? All good, Okay, I'm going to stop first. Wait, tired or not? Hold on, let me delete my slide first. I have another slide for you. Normal distributions. I just go a quick one, touch and go. Can another 30 minutes, okay lah. Okay. So for these chapters for normal, I will first discuss about normal distributions, followed by the applications. Okay. After you complete the chapters, you should be able to identify the properties for a normal distributions, followed by identify whether the distribution is a symmetric or a skewed distributions. Then find the area under the normal curve when you're given a variance z value. Then find the probabilities of a normally distributed variable. How? You transform it to the standard normal first. Okay, finally, find a specific data value for given percentage using the standard normal distributions. This one I don't think I can cover. I can only cover a few parts only. Okay, so when we say random variable, just now we have a variable followed by random variable, and we have actually discussed the discrete random variable. So now we also have continuous random variable. So we have also covered just now. Random variable is, for example, something like continuous variable is something like you measure. Okay, let's say you measure your temperature, you measure your weight, you measure your height. So all this is continuous variable. And most of the time, the continuous variable, they will have a distributions where it looks like a bell-shaped distributions. So when we have the shape that is like bell shape, we call it as approximately normally distributed variable. It's very long, but you can just say it's a normal curve. So when you have a random variable where the probability distributions, the graph is continuous. Okay, it looks like there is no breaking. There's no breaking. It's like a smooth curve like this, and then it looks like a bell shape, and you can see like it's symmetric. Symmetry means that you have a center, and then the left side and the right side it looks like the same. So this one is a normal distributions, and the curve we call it as a normal distribution curve, or in short, normal curve. Okay, normal curve looks like a bell shape curve, just a bell shape. So normal distributions, the shape and the positions, okay, how it looks like, and then where is it, to the left or to the right, it will very much depends on only two parameters. One is the mean, another one is standard deviations. So each of the normally distributed variable, it will have their own curve. So this curve will depends on its mean and standard deviations. So it depends on where is it. Now, let's say you look at this. Look at the A. So I have a I have a blue color curve and the brown color curve. So what is the difference here? Both the mean is equal to 0. So you can see here, my mu equals to 0, which my mean. So they are at the center here. So both at the center, the location is the same. But the difference here is the sigma. Sigma is the standard deviation. It shows you the dispersion of data. So you can see for this brown color, it is slimmer as compared to the blue color curve. Blue color is flatter. So why? Because the standard deviation is larger. Okay, so it's flatter because it's spread wider as compared to when your sigma equals to 1. So you can see that you have a same mean, different standard deviation. So they are at the same place, but the shape is different. Now you look at B. So what's the difference here? The shape is the same. The shape is the same, just that the location is different. So why the location is different? Because of the mean. One, for the blue color one, the mean is 0. And then for the brown color one, the mean is 2. So you can see that when you have 2 here, so it will move to the right side of 0. But both with standard deviations 2. Same standard deviations, so it means that the spread is the same. That's why you can see the shape is the same, just that they are located at different area. Okay, so this is how it looks like. So what is summary when you have a normal distribution curve? So what is the properties? So normal distribution curve, bell shape, looks like bell shape, and mean equals to median equals to the mode. Okay, they are the same and they located at the center. And normal distribution curve is a unimodal. You have only one mode. Okay, only one mode. You don't see bimodal and so on. It's only one mode. And the curve is symmetric about the mean. So it's centered at the mean, and the left hand side and the right hand side, they are the same. The curve is continuous. There will be no gap, no holes. And here, curve never touch the x-axis. You can see that it's a floating on the x-axis. It will never cross the x-axis. The total area under the normal curve is equal to 1. Area under the normal curve is actually the probability. So the total of the probability is actually 1. And when you want to convert it into the percentage, so it's actually 100%. And then we have this. This is empirical rules. So we can actually say that within one standard deviation of the mean, you will have about 68% of the data. Okay, 68% of the data will lie between mu minus sigma and mu plus sigma. And you have about 95% of the data will lie between mu plus minus 2 sigma. And you have about 99.7% of the data lies between mu plus minus 3 sigma. So let me show you a graphical area. Okay, something like this. So you see, you have a normal curve. Wait. You have a normal curve over the x-axis. It will never touch the x-axis. It's floating. You can see I have no cross the x-axis, and it's a smooth curve. You don't have a gap. There is no gap here. It's a smooth curve here, and it's unimodal. There's only one mode here, and your mean equals to the median equals to the mode here. It's here. So you can see that this part is the same as this part. It's like a mirror. So they are symmetric. And what is the meaning of like 68%, 95%, and 99.7%? How we derive into this? Okay, don't ask me. This is the rule, empirical rules. Okay, empirical rule says that you have 68%, roughly 68% of the data lies between mu and plus minus 1 sigma. So here you have around 68% of the data, and when you have like mu plus minus 2 sigma, so from here to here you will have about 95%. Then when you have like mu plus minus 3 sigma, so you will have almost 99.7% of the data lies within here. So where is the remaining 0.3%? So the remaining 0.3%, you will go into the left and the right. So 0.15 to the left and 0.15 to the right, which we actually often we call it as a outlier, okay, which is a rare case that is not normal. All right. So here, what is the difference like a normal curve and the skewed curve? So for normal curve, it looks like this. Okay, the center mean equals to mode equals to median. But if you have something like this, where your mode is the largest number, followed by the median and the mean. So your mean is smaller, mean smaller than median, and then your median smaller than your mode. Then this one we call it as a negatively skewed. Okay, negatively skewed means you skew to the right. So how to remember this? Means that, okay, you're sitting here, you're playing the slide. Okay, you go to the left hand side. So left skew. Okay, whereby for this one, you're sitting over here, you play the slide, you towards the right side. This is right skew. So for right skew, your mode is the largest, is the smallest number, then followed by the mean, median, and your mean is the largest number. So this one, we call it as right skew or positively skewed. So why we say positive or right skew? Because it goes toward the right side. So when you have an axis, right, you can see the x, right? So when you go to the right side, the numbers get larger. That's why it's positive. Similarly, for this negatively skewed, why we say negative? Because when you go the x-axis, when you go toward the left hand side, your numbers get smaller and smaller. That's why we say negatively skewed. Okay, now how about standard normal? Just now I mentioned every normal curve has its own mean and standard deviations. So how about a standard normal? So when we call the normal curve as a standard normal curve, it means that your mean is 0. Your mean 0, standard deviation is 1. So when you have like mu 0 and you have like mu plus 1 sigma, mu plus 2 sigma, mu plus 3 sigma. Same thing goes to here, mu minus 1 sigma, mu minus 2 sigma, mu minus 3 sigma. So you will see that the curve, when you have standard normal, so your data is ranged between -3 to 3. All right. So same thing, you have 68% of the data lies between -1 to 1. 95% of the data lies between -2 to 2. And you have 99.7% of the data lies between -3 to +3. The remaining is less than -3 and greater than 3. So this is how standard normal looks like. So why we need standard normal? Okay. I believe that later Dr. Isni will share with you the normal curve, the normal distributions. So you have only one table. So as I mentioned, each normal distribution have its own mean and standard deviation. So if we have so many, there will be many curves, and then you will have many tables, which is impossible. That's why we only have one, which is standard normal distributions. So how we actually convert regular normal distributions into a standard normal distributions? How we do that? We just take the value that we have minus the mean divided by the standard deviations. So usually for standard normal distributions, we denote by Z. The variable denote by Z. For the normal one, the regular normal distributions, usually we use X. Generally use X or Y, it doesn't matter. So what is actually this Z mean for? You have the mean, the value minus the mean divided by standard deviation. What is this? This is actually a form of how you standardize it. We call it as a Z score. So it actually tells you the numbers of standard deviations that a particular X value is away from the mean. So how far it is away from the mean. When you have positive, means that it is above the mean. The value X is above the mean. When you have a Z is negative, means that the value is actually below the mean. And when you have 0, it means that the X actually equals to the mean. So let's look at this. So how we can actually get the corresponding area for the Z value under the standard normal curve. So we can do multiple ways. You can either use the standard normal table, like I told you just now, the table, or you can use calculator, scientific calculator. You can also use software. or you can use like Microsoft Excel or some other statistical software also it can be done. So these are the table that I use in UCSI. I'm not sure whether yours is the same or not. Okay, each of you will have a different table, but you just need to clarify that your table is actually towards the left hand side or towards the right hand side. So for the table that I use here, I have actually the area to the left. Okay, area to the left. So what's the meaning here? Okay, I have a Z. Okay, you can see like negative 3.4, negative 3.3, and so on. And I have these two. So what is this actually mean for? This means the second number here. For example, my Z negative 3.4. So it's actually this. Okay, so let's say negative 3.07. So I get this. So this is actually the second decimal for this Z value. And for the table that I have two pages. One page is for negative value, range from negative 3.4 to 0. And I have also another page from 0 to positive 3.4. So what is actually all these numbers stand for? It actually tells you the probability, okay? Or it actually tells you the area under the curve. So let's say, what is this 0.0003? What is this actually? So it means here, when your Z is negative 3.45. So here, when it's negative 3.45, your area is 0.0003 to the left. Okay, this is what it means. Can you follow me? Can you follow?
Yes.
Okay, good. Now, how we actually find the area under the standard normal curve? So, if you are looking for an area to the left of any Z value, so very easy. You just check on your table, you just look up the Z value and then use the value. Done, you get it. So either it's positive or negative. The center is 0 because standard normal mean is 0. And if you are looking for an area to the right side of a Z value, so in this case, my table only give me area to the left. So how am I going to get the value to the right? So I use 1 minus. Okay, I can use 1 minus, or I can use mirror. Mirror means that if I have this one, you see, area to the right of negative Z is actually the same as area to the left of positive Z. So it's a mirror. You can do two ways. Either you use complement 1 minus, or you use mirror, okay? Because they are symmetric. So what if you're looking for an area that is between two values, for example, like this? So you look up both Z value and subtract the corresponding value, area. How it looks like? So my table give me area to the left. So I'm going to take this bigger piece here minus this one. So I get back this center. So this is how I do it. Now, let's say I need to find the area under the standard normal curve to the left of 1.73. So it looks like this. You have a normal curve, center put 0. So 1.73 is actually positive number. So put it somewhere here. Okay, your curve should be between negative 3 to 3. Yeah? So 1.73 somewhere here. And you're looking for area to the left of 1.73. So you shade this region. Then, so since this one, you're looking for the area to the left. So when to the left, it means that you can straight away get it from a table. So I just need to get here 1.7 and then 3. So I got this, which is 0.9582. Okay. So from here, I can turn it into mathematical form. So probability Z less than 1.73 is actually equals to 0.9582. Okay, I move faster. You have not enough time. Okay, now, let's say I'm looking for the area under the curve to the right of negative 1.24. So again, you draw a curve, then your negative 1.24 is to the left side of 0. So draw a line first, and you're looking for area to the right. So when area to the right will be here. Okay, shade these regions. So what happened here is my table give me area to the left. So I need area to the right. So what can I do? What can I do? Use 1 minus. Okay, you can use 1 minus. So you use entire. Okay, entire, as I mentioned, the area under the normal curve, the total area is equal to 1. So entirely is 1 minus this one. Then you will get back this. So 1 minus z less than negative 1.24. So you can get it from a table, negative 1.24, which is 0.1075. So 1 minus, you get 0.8925. Then, now, alternative way. Just now we are using 1 minus, which is complement. Another way is I use mirror. So you can see that actually, if you are looking for this area, there actually is the same area as this. So area to the right of negative 1.24 is actually same as the area to the left of 1.24. So from here, once I have this, you can turn it into this way. So this is for the first one, and this is less than for the second one. So when you have less than 1.24, you can straight away get it from a table, 8925. So you see, you get the same answer. Either you use a complement or you use symmetry. Okay, both are the same. Now, if I'm looking for the area under the curve that is between negative 1.35 to 1.62, so draw a normal curve, center put 0, then draw 1.62 and 1.65, negative 1.35, shade it. Okay, shade the regions. So these are the area that you're looking for. So what we do, based on the table that I have area to the left. So what I do, I take this area, okay, minus this area. So I get back the center. So this area is z less than 1.62, which is here. And then this one is z less than negative 1.35. So from here, turn into mathematical form. Okay, you are looking for this area, then minus. So get from a table, you will get 8589. So how I got this? Okay, 1.62 and negative 1.35. How I get this number? Here, 1.62, I get 9474. And then negative 1.35, I get 0.0885. So I minus these two, I get the answer. Now, if I'm looking for this area between 0 to 2.53. So between 0 and 2.53, so same thing. You take the larger area minus the smaller area. And this one, because it's half of it, is actually 0.5. So you can straight away get it from a table. This one you know it is 0.5. You will get the answer 4943. Okay, we move on. Let's say it's a standard normal. I'm looking for the probability z less than 1.73. So draw a line here. Okay, this one straightforward. Straight away get it from a table. Okay, you can get 0.9582. And for this, when you have z greater than 1.98, okay, give me a moment. Okay, so this one to the right side. So our table don't have area to the right. I have area to the left. So I can use 1 minus the unshaded regions. So I will get back this. So I get 0.0239. And let's see what I have. Alternative way. So I can also use symmetry. So this one, this area to the right of 1.98 is actually same area as to the left of negative 1.98. So from here, actually equals to this. So I can get it from a table. Then, okay, now, alternative way. So find the z value such that the area under the standard normal curve to the left of z value is 0.7123. So it means that, okay, when you have 0.7123 for sure, it's here because the center already give you 0.5. Okay, from here, 0 to the left is 0.5. When you're looking for 7123 means here. So I'm expecting that the z value is a positive number somewhere here. So shade it. So what I do, I will go into the table and look from inside which number that give me 0.7123. So we can see that it's actually here. I found it here. So I go back here. I notice that the value z is actually 0.56. So I can actually show here. Probability z less than 0.56 is actually 0.7123. So this one is 0.56. Okay. Next, okay. Ideally, there is a shortcut. When you have a table that gives you area to the left, so if you have something like this, which is less than 8, you can straight away get this from a table, straight away. And let's say you have greater than something, then either you use complement, which is 1 minus z less than, or you use the mirror, symmetry. So you change the greater sign to be less than sign. If you have a positive number, you change to negative number. Just change the symbol. And you have, if you have like a z that is between A and B, then you just take the bigger size, the bigger piece, minus the smaller piece. So you get the answer. You will get the answer. This is the shortcut, okay? The general formula. And should I stop here, Dr. Isni, before I go into the application? Dr. Isni,
I think you can proceed to at least show them one or two example if you
okay,
have.
can I have? All right.
Thank you.
So standard normal curve can be used to solve wide variety of practical problems. So usually what we do here is we convert the usual normal distributions into standard normal. So by doing how? Same thing like I show you. You take the value minus the mean divided by standard deviations. So let's say applications. So you have a score for the test is a normally distributed variable. The mean is 100 and you have a standard deviations of 15. So you can actually draw a line. Okay, standard normal center is 0 and then standard deviation is 1. So you know that it lies between -3 to 3. So for this one, normal curve, your mean is 100. So you know that this is actually 100. And your standard deviation is 15. I can actually have like the one standard deviation is 100 plus 15 is 115. And then 100 minus 15 is 85 and so on. So this is how we actually convert it. Okay, your x value, I can convert the what we call. Okay, this is just to show you how it works. I show you the example. Okay, how we actually find the area under the normal curve. You draw a normal curve. Okay, this one I skip. I show you the example. Okay, now has on average 5.2 liters of blood. Assume that the variable is normally distributed. Standard deviation 0.3. You are looking for a percentage of people who have less than 5.4 liters of blood here. So how we do? We know that our mean on average is 5.2. Standard deviation 0.3. You're looking for the percentage means probability, which have less than 5.4 blood. So my x less than 5.4. So what I do here, okay, you can draw a curve, okay, normal curve. I know my average is 5.2 and I'm looking for area less than, okay, 5.4, less than 5.4. So 5.4 is to the right side of 5.2 and you shade this region. Why? Because it's less than. Your question asks for less than, so I shade this region. So I'm going to convert this into my z. This is my x, my x. We need to convert to z first. So from x to z, so I minus the mean by standard deviation. This one, you can straight away use z, whereby the 5.4, okay, 5.4 is the x value. You minus the mean, which is 5.2, divided by the standard deviation 0.3. So from here, simplify, you get the z less than 0.67. Okay, this is how I get it. Here is x, here is z. So once you have less than 0.67, you can get it from a table, okay, which is 0.7486. So this is how it works. The applications, you convert from x to z, then you use table to get it, or you can use calculator as well. Then, okay, the question asks for the percentage. So for sure, probability, multiply by 100, you will get percentage. So you will have about 75%. 75% of the adults will have less than 5.4 liters of blood in their system. So this is how we answer the questions. So let's move on to, let's say this. You have a Malaysian household generate average of how many kilo? I cannot see. 28 kilograms of newspaper for garbage or recycling. So assuming that this variable is normally distributed, your standard deviation is 2. So you select a household at random. You're finding the following probability. So between 27 and 31 or more than 30.2 kilogram. So let's say move on to the first one. Your mean is 28, your standard deviation is 2. So I get this information. Then this one, between 27 to 31, I can use this. Okay, you might wonder why I never use equal sign. Okay, for continuous distributions, with equal or without equal sign, it doesn't carry any difference. Because equal sign, when the area under the curve for the equal sign is actually equal to 0. So usually I will just remove the equal sign here. So it's between 27 to 31. And this one, more than 30.2. So greater than 30.2. So we were going to convert it into z first. So from x to z. So 27 minus mean divided by standard deviations. Same thing, 31 minus mean divided by standard deviations. Simplified it. So you come to Z, then you just follow the previous guideline. You take the larger part, which is Z less than 1.5, minus the smaller part, less than negative 0.5, and get it from a table. When you have come to this less than sign, you can straight away get the answer from table. Then you will get the final answer 0.6247. And for the next one, okay, this is just explanations. So if you have more than 30.2, same thing. 30.2 minus 28 over 2. Never change the inequality symbol. We only convert the value. We never change the symbol. So the x become z. So it's actually 1.1. So again, this is greater sign. We can't find it from a table. We have to use either 1 minus or you use complement. So this one, if I use 1 minus, I will get 0.1357. I think I have to stop here. Okay, Dr. Isni?
Okay, thank you. Okay, everyone. Are you there, everyone? Still got energy?
Yes, you know.
Okay, wonderful. All right. Okay, thank you so much, Dr. Loh, for very informative sharing and very good explanation. I think all of the students here taking notes and also
Sure.
here and there understands. Okay. Anyway, now let's open the floor for question and discussions, Q&A session. If you have any comment, you can raise your hand, which is by click the reaction button, and you can unmute your microphone lah. Okay, open the floor to all of the students here. Q&A, please. Any question? Just open the mic, don't shy.
Sorry, the time given is too short. Usually I spend few hours for these two topics.
Maybe next session.
Yeah, it's crazy.
Okay, guys, got any questions? Just open the mic. Don't shy.
No questions?
Hello? Can you hear my voice?
Ilmi? Madiha?
Yes.
Yes, anything?
I represent S37. I want to ask, is there any careless mistakes you have seen students do that we should know of? That's my questions. Thank you.
Again, is there any careless mistake?
You have seen students do that we should know of.
Know of?
I rasa soalan dia, you ada tips tak untuk student avoid any careless mistake? Macam ada tak in statistik in normalization ke Poisson or binomial that student tend to do careless mistake? Any part? Is the question, Ilmi?
Let me see the questions in the chat box. Let me see.
Is there any careless mistake you've seen student do? Yelah,
It's not some kind of careless mistake. Most of the time I can see is student use the wrong inequality symbol. So this is the part. They use the wrong inequality symbol. And also, because we are dealing with a lot of numbers, you have like decimal places and so on, right? So you need to key in, you have to use your calculator. So student tends to like, let's say 0.0668, it becomes 0.668. End up everything wrong already. So this is the part that I often see when a student did careless mistake here. The decimal, when there's a decimal place, let's say 0.0668, student mistakenly put it as 0.668. So it's wrong. Okay.
Yes, agree. Decimal places also play this.
Decimal places use the wrong inequality symbol.
Okay, next question. Could you explain how problem distribution
Just now my example
applies to real world scenarios?
My example a real world scenario.
Could you explain how probability, I think probability distribution apply to
Oh,
real
okay.
scenario.
Okay, let's say you mean the probability.
Camila? Yes, okay.
Just a simple example. You check how many the clothes, right? The colors that you have. Then you can see how likely you will wear, like for example, black color to the class and so on. Or let's say you have of course I know girls will have a lot of shoes, right? You have high heels, you have sports shoes, this and that, right? So you can actually predict how likely you will wear high heels maybe on Friday, or how likely you will wear sports shoe on maybe Wednesday. This one also we can apply actually.
Okay, interesting. Very good questions, Camila.
Answer in percentage? Huh? Which one? What do you mean by answer in percentage? Zoo? What's compulsory thing that should be in our working step? Oh, 0.0. You multiply with 100. 0.6678, you multiply by 100, you will get around like 66.78. Or you can just make it like 67%. The one is okay. The one is just for explanation part. The compulsory things to do means never skip step. Okay, compulsory things that should do in your working step, never skip step. Do one by one. Step by step is okay. And
Yeah.
whenever you are dealing with number, you have time, try to press your calculator 3 times. Okay, this is the practice that you can avoid mistake.
Yes, very good. And then I would like to add for the question from Zul. Can you give your answers in percentage? Yes, it can because the percentage is also part probability.
Yes, it's the same
Okay.
meaning.
Maximum 100%. Okay. Next question. No more question. If no question, can I have a reaction? Clap hand or any reaction if no question so that I can close the. Okay, we have
Wait,
another question.
there's a question. Answer in standard form. Decimal, the only compulsory one. No. Up to you. Actually, if you can put it in fractions, means that it's exact numbers. You can also put it in the decimal form. But usually, for my practice, for probability, I leave it in 4 decimal.
Okay, anything else? Any more questions?
There is a question.
Okay.
Probability distributions, normal, binomial, Poisson. How we determine it? Okay, normal is for continuous case. When the variable that you use like measurement device to measure it, then it's continuous. And if it is normal, okay, and binomial Poisson is actually discrete case. The data that arise when you count. And for binomial, you can actually easily see there is a numbers of trial and also the probability of success. Whereby for Poisson, you won't see this. For Poisson, you will often see lambda, like on average. And then you have some, like for example, a certain period of interval and so on. You can see the difference. If you read through, you can actually capture like the type of questions.
Okay, all right. Very good question and answer. And then I think Dr. Loh got another question there. Siti Fatiha, will there usually be a range of answers since students may use different decimal places?
Yes. So we won't mark the student wrong, although they are, for example, I say leave in 4 decimal, but if the student answer in 2 decimal, I cannot mark the student wrong.
Yep.
The one is okay. It's okay. So long the working is correct.
Okay. Any more question? If no, then can I have reaction? No reaction for no. All good?
No reaction for no.
Yeah, so that I can close
Okay.
the session. Okay, so we have the reaction, so I can close the session.
Thank you so much for being with me at this hour. It's your Friday night.
Belum lagi.
Belum.
Okay, so before we conclude, I want to express our gratitude to Dr. Loh Yufang for sharing your expertise and also you guide all of
My
the
pleasure.
students and also all the lecturers here through this discussion. And then your insight have been very invaluable and we really appreciate your contributions until 10 p.m. Okay, And also to all of my beloved students here, I want to thank all the participants for your very supportive engagement. Your contribution have made this so-called collaborative teaching sessions very truly wonderful and enriching. Okay, so before I give you the attendance form for your curriculum mark, so let us take the photo, and I hope all of you open the camera. Show us the very, very handsome and beautiful face. Okay, everyone ready?
Belum oh.
Belum oh? Okay, jap.
Pakai tudung dulu.
Pakai tudung semua, buka kamera, open the camera. Yang makan-makan kat anjung tu, stop kunyah. Okay. Stage. Macam mana I nak susun dia
Sorry, I have to teach very fast because I only have 2 hours.
It's okay. This one also is very, very, apa tu orang kata, penuh knowledge. Okay, so I count. Sekejap ni. Okay, ready everyone? Smile. One, two, three. Okay, wait for a while. I have another page. Wah, dapat belon
Wah, dapat balon lagi.
Okay, 1, 2, 3, everyone, smile. Okay, ada lagi page. Sekejap
Ramainya.
ada lagi. Ramai.
Wah, 1 to 1 Wow.
Okay. Alright. Okay. And then page ni banyaknya. Sekejap. Banyak pula. Okay. Okay, dah habis page. Okay, everyone.
Okay.
Okay, thank you a lot, Dr. Lo.
Thank you. Thanks for the chance.
Alright, thanks. Okay,
Thank
student,
you.
you have to remain here. I will give you the attendance form. Thanks,
So
Dr.
I
Lo.
will-
Bye.
Thank you, Doctor.
Thank you very much.
Thank you, Doctor.
Thank you, Doctor.
Bye.
Good night.